solving quadratic functions, solving quadratic equations. This is section 2. We're going to solve quadratic equations using different methods. And a quadratic equation is any equation that can be written in the form of ax squared plus bx plus c is equal to 0, where a is not equal to 0. Because if a were equal to 0, it would be a linear equation. A root or a solution of a quadratic equation is a value of the variable that satisfies the equation. So first of all, I am going to solve that first equation by factoring. But I can't factor it right away because it's not in the right format. I don't have it equal to 0. So what I'm going to do is I'm going to FOIL the left side and then move the 11 over, and then I'm going to factor it. So when I FOIL that, I get 3x squared plus 12x minus 2x minus 8 is equal to negative 11. Combine your like terms and you get 3x plus 3x squared, plus 10x minus 8. Move the 11 over, so add 11 to each side, so plus 11 equals 0. So then I have 3x squared plus 10x plus 3 is equal to 0. So let's factor it. So when I factor it, I do 2 sets of parentheses, and I have a 3x and an x in my first spots. And since these are plus, I know it's going to be a plus and a plus. And the only way to get 3 is either a 3 there and a 1 there, or 3 there and a 1 there. And hopefully you know that where they go. And so when I solve it, I'll get x is equal to negative 1/3. X is equal to 3, or negative 3, when I solve them. X is equal to negative 1/3. X is equal to negative 3. And you're done. So that's factoring. Solve by the square root method. The left side is 2x minus 3 quantity squared. So I could just take the square root of each side. Instead of multiplying it out and then moving everything over like I just did, it's a lot faster this way. So if I take the square root of each side, I end up with 2x minus 3 on the left, and I end up with plus or minus 5 on the right. Solve this equation, add 3 to each side. Oops, I'm solving it twice. I guess I'm going to do it this way. Okay, so it's equal to plus 5 or minus 5, so add 3 to each side. And you have 2x is equal to 8. 2x is equal to negative 2. Divide by 2. You have x is equal to 4, or x is equal to negative 1. And that's much faster than foiling it, moving everything to one side, refactoring it, or it's much faster this way. Solving by completing the square. I want to solve 2x squared minus 12x minus 7 is equal to 0. And we've done this before a few times. When we worked with circles at the beginning of the year, we completed the square. Just last sections, we did completing the square. So, to complete the square, your coefficient of your x squared has to be 1. This is not. So I'm going to divide everything by the 2. Because if I divide everything by 2, I will have a coefficient of 1. So I have x squared minus 6x minus 7 halves is equal to 0. Okay? Next step, I'm going to move the constant term to the one side. So to the other side, I'm going to move the constant term. So then I have x squared minus 6x is equal to 7 halves. And now to complete the square, remember, you take half of this negative 6, which is negative 3, and square it. So to complete the square, that's the next step. Add the square of 1/2 of the coefficient of x to both sides. And that's what I said to do. So negative 3 squared is what we'll be adding. So I have x squared minus 6x. I'm adding negative 3 squared to each side. And then this right here is right there. That's all that is. okay? This factors into that. You do not need to multiply it all out and then do the 2 sets of parentheses. It's always this number. Let me just do this one. So I have this number without the squared and this number without the squared, minus 3, okay? The right side, I have 7 halves plus 9, this ends up to be, and 9 is 18 halves. 18 plus 7 is 25 halves, okay? And now it's a perfect square like that last one. Oops. There. So take the square root of each side. So I end up with x minus 3 is equal to plus or minus. The square root of 25 is 5. The square root of 2 is 2. And then add the 3. Do I have it written anywhere? Let's see, where do I have it written? Don't know where the last part is, but I will rewrite it for you. X is equal to 5 over radical 2 plus 3. And on a test, I would probably have you get the radical out of the bottom. So you would tell me that x is equal to 5 radical 2 over 2 plus 3. And you could just do it just like that. Okay? Plus or minus. And you're done. That's completing the square. Solving by the quadratic formula. Quadratic formula. Remember the quadratic formula. The opposite of b, plus or minus b squared minus 4ac all over 2a, where a cannot equal 0. So if I want to solve that equation there using the quadratic formula, the first step, you need it in the format where it's equal to 0. So I need to move the 4x over to the other side. So rewrite in standard form. So there's written in standard form. And now, there's your A, there's your B, there's your C. A, B, and C. So plug it into the quadratic equation. Why don't you pause this for now, see if you can do it, see if you end up with 1 plus or minus I radical 10 over 2. So let's see what we get. Here, I'm plugging everything in. The opposite of b, so the negative of negative 4 is positive 4, plus or minus b squared, so negative 4 quantity squared is 16, minus 4 times 2 times 7 over 2 times 2. 4 times 2 times 7 is 56. 16 minus 56 is negative 40. Radical 40, I can think of 40 as 4 times 10. 4 times 10, I can bring out the 4 so the 2 can come out in front. And also there's a negative, so an I can also come out. So, I guess I wrote it a different way, which is fine. I wrote it as 4 over 4 plus or minus radical negative 40 over 4. That's how I got that. And then, this is what I was just saying before. The 2 comes out, and an I also comes out in the final. And 2 over 4 is 2. Not the only way you could do it mathematically. I could have, from here, just done 4 plus or minus 2I radical 10 over 4, and then factored out, factored from the top. If I wanted and written it differently, I could factor out a 2, and I could have written it as, if I factor out a 2, minus I radical 10 over 4. I could have called it 2 plus or minus I radical 10 all over 2 if I wanted. And that would have been right also. Okay? What is under the radical, the b squared minus 4ac? That is called the discriminant. And the discriminant can tell you something about the roots. If if the discriminant is a negative number, like this, it's negative, you'll have two conjugate imaginary roots. And what it means, I hope you know what a conjugate, because you have 2 plus I radical 10 over 2 and 2 minus I radical 10 over 2. These are conjugates, the plus, the minus. If what's under the square root, that discriminant, is equal to 0, there's only one root, and it's called a double root. If it's a positive number under the radical, there are two different real roots. Okay? Figuring out what method to use. Quadratic always works. But the problem with quadratic formula, if you do this on every problem of a test, you will never finish a test. So you should use the fastest method available. Okay? So if a, b, and c are integers, and b squared minus 4ac, it's a perfect square, then factoring the equation. Okay? If the equation has the form of x squared plus an even number times x plus a constant, completing the square is pretty easy to use. So you kind of have to figure out what to use and when to use it, and practice will get you there. Okay? But quadratic always works, but you don't have time to do quadratic for everything.